So here is 5.2 continued, and this first example, we're going to look at how we can take cosecant squared x, and we want to change that so the whole expression is in the same trig function. So we're going to take cosecant squared x, and we're going to use the Pythagorean identity, and we're going to change it to 1 plus cotangent squared x. Then we still have subtract cotangent x, and then we have subtract 3. So from there, I've got cotangent squared x, subtract cotangent x, and then 1 subtract 3 is a -2. Now this expression you can factor, just like you would factor x squared minus x minus 2. So if you want, you can say, I'm going to let cotangent x equal u. And then this would give you u squared subtract u subtract 2. So if you don't like the cotangents, just replace them with a u. So then we have our two parentheses, u times u is u squared, 2 times 1 is -2. I need this one negative and this one positive. Once you do that, you would take your u's and put back in your cotangents. So now my final answer is cotangent x subtract 2 times cotangent x plus 1. All right, and there is my value. And let's look at C. So C is secant squared theta minus 1. The first thing I feel like doing is I want to do a plus b, a minus b, and factor it. But in actuality, there's something easier because this, I can use my Pythagorean identities, and that is equal to tangent squared theta. So you can see how easy that is. So there's my solution. Okay, let's go to D. I have 4 tangent squared theta plus tangent theta subtract 2. So I'm going to go ahead and write this with a u. In my Cornell, I'm going to let tangent theta equal u. So now I have 4u times u is 4u squared. Oh, by the way, this is 4u squared plus u minus 3 is what I'm trying to factor. So I need that 3 times 1. So if I put the 3 here and the 1 here, outsides is a 4u and insides is a 3u. So subtract the 3u, and that will give me just a positive u in the center. So I did that by guess and check. You could do that by split the middle or the AC method. There's a whole bunch of different ways to factor. So from there, I've factored it, and so now I'm just ready to go ahead and put tangent back in for u. Final answer is 4 tangent x, oh, it's a theta. So sometimes they use theta, which is the angle. In calculus, you use x a lot because that's going to represent velocity or some sort of real, instead of just an angle, it might represent speed or location. So for tangent theta, let's see, subtract 3, lost my train of thought, and then u, tangent theta goes in for, so tangent theta plus 1. And here you go. This is a trig identity. It's equal to the original. It's just a different way to write the original. Example 5, we have sine x over 1 minus cosine x over sine x. And so looking at example 5, the first thing we're going to do is we want to get common denominators. So just like you would with regular fractions, this first fraction, you would multiply the top and bottom by sine x. And the second fraction, you'd multiply the top and bottom by 1 minus cosine x. Let me show you over here. So we have sine x over 1 minus cosine x, subtract cosine x over sine x. So multiply this one, top and bottom, by sine x. And then over here, you're going to multiply the top and bottom by 1 minus cosine x. This is how we get a common denominator. Now, see the subtraction in the middle? I get really worried that you're going to mess up with that subtraction. So you may want to write this as plus a negative, and then you're going to take negative cosine x and multiply it through that parenthesis. So the first one is easy. Sine x times sine x is simply sine squared x. So I have sine squared x, and then it's I've got a negative cosine x times 1 is negative cosine x, and then a negative cosine and a negative cosine is a positive cosine, put the square right here, x, cosine squared x. The denominator is that common denominator of sine x and 1 minus cosine x. Now, I recommend, you always want things to cancel, so I recommend don't distribute the denominator, leave it factored. Okay, so on the top, you can see here that I have a sine squared x plus a cosine squared x if I were to change the order. And that's Pythagorean. Sine squared x plus cosine squared x happens to equal 1. So I can say that this is 1 subtract cosine x over sine x times 1 minus cosine x. Now what we're going to do is we're going to cancel the 1 minus cosine x's. That leaves you a 1 on the top. So now I have 1 over sine x, and sine x, 1 over sine x, remember who sine x loves? Sine x loves cosecant. So this equals cosecant x. So example 6, it wants us to rewrite 1 over 1 plus sine x, and so that it is not a fraction. So to get rid of the fraction, we're going to multiply the top and the bottom by the conjugate. And so the conjugate of 1 plus sine x is 1 minus sine x. So 1 minus sine x, and you're going to multiply the top and bottom of that fraction by 1 subtract sine x. Now the denominator, you're going to FOIL that, and these are conjugates. So first times first is 1, and then outside insides cancel, and then last times last is subtract sine. Remember, you put the square here, sine squared x. The numerator is 1 minus sine x. Now, if you notice, 1 minus sine squared x, if you look at Pythagoreans, that's going to be equal to cosine squared x over 1 minus sine x. From there, you're going to split the fraction. So you notice there's a subtraction sign here. That subtraction is going to go in the middle. You have common denominator of cosine squared x and cosine squared x. And then this numerator would be 1, and this would be subtract sine x. So if you were to put these two fractions together, you come, oh, sorry, I don't know why that's vibrating like that. All right. You'll get that fraction there. Now 1 minus cosine squared x is the same thing as secant squared x. We remember that cosine loves secant. So this would be secant squared x. And then you still have subtract. And we're going to take this fraction right here, and we're going to break it up into 2 parts. Now, there's not an add or subtract sign. It's straight multiply. So you would have sine x over cosine x times 1 over cosine x, because there's no subtraction there. If I multiply this, I would get this fraction right here. Okay, so from there, we are almost done. So we can say, well, sine over cosine happens to be tangent, and 1 over cosine happens to be secant. So you could write this as, I wish I had more room. Let's see if I can scroll down. There we go. So final answer, and this is still not super simplified, but the question was to write it without a fraction. And I can do that right here because I have secant squared x subtract sine over cosine is tangent x. and 1 over cosine is secant x. So I was able to rewrite that fraction as without having it be a fraction anymore. So here's the original, it's a fraction, and here's my answer, which is no longer a fraction. All right, let's look at example 7. Numerically means that we're going to do this algebraically. And then you could also graph it on your graphing calculator. Numerical would be putting it into the calculator and looking at the table. And then graphically is going to be graph this in the calculator. So if you were to graph this in the calculator, under y1, you would graph cosine 3x. And under y2, you would graph 4 cosine cubed x minus 3 cosine x. By the way, in the calculator, when you graph, it would be 4, and then you would have to do a parenthesis, and then cosine x, close the parenthesis, and then you would put the cube there. So that's what the calculator is going to look like. So I really encourage you to try this on the calculator. And then let's go ahead and verify it algebraically. So looking at this algebraically, and I'm not sure, you guys, why my arrow keeps bleeping like that. Don't know. All right, so there we go. So looking at this, I recommend just doing this one numerically and graphically using the calculator. So give that one a try, and if you have questions on it, will you make sure you ask me in class, and we'll graph it with the calculator in class. All right, looking at example 8, x equals 2 tangent theta. We know theta is between 0 and pi over 2. This is just a clue to tell us that theta is positive because we're in quadrant 1. And we want to write the square root of 4 plus x squared as a trigonometric function of theta. So what we're going to do is, in place of x, we're going to use the trig function 2 tan theta. So here we go. We're going to write this square root. We've got 4 plus, and then in place of x is going to go 2 tan theta, and then that is squared. All right, so now what we're going to do is we're going to look at squaring. And sorry, you guys, I'm distracted because this is bleeping weird, but this video is almost done. I'll fix it for the next video. So now I have 4 plus, when you square 2, you get 4, and when you square tangent, you get tangent squared theta. All right, from there, when I draw this line, it means I'm going to come back up to the top. I'm going to factor out a 4 under that square root, which gives me 1 plus tangent squared theta. Pythagoreans. So look up your Pythagoreans. What is 1 plus tangent squared theta? That's secant squared theta. So now I have the square root, and I still have a 4 here, and then I have a secant squared theta. Now that there's not an add sign, take the square root. So the square root of 4 is 2, and the square root of secant squared theta is simply secant theta. And I just rewrote that as a trig function, and your final answer is 2 secant theta. Now, something that you might want to do is, because we know this came out of a square root, we know that the secant theta part has to be positive. So a lot of times you'll see this one with the absolute value symbols. So go ahead here and put in a reflection, maybe one of these examples you need help with in class, or just a simple, I get this, or whatever you want to put in your notes here. And this was identifying trig functions using trig identities. So basically rewriting trig functions that are equal. Thanks, everyone.